So hello guys, I hope you're doing fine. This is our second class after the previous one that we did that involved introduction to matrix, algebra. We also tackled identifying elements in a matrix, the types of matrices, and the transpose of a matrix. So today we are doing something different. We said we are going to operations on matrices, and we're starting with addition and subtraction, then we go to multiplication. So if you haven't viewed the previous class and you don't understand, you can please go back to the previous class and then join us on this one. But either way, let's now start. So matrix addition and subtraction, we can add any number of matrices or subtract one matrix from another if they have the same size, or they are of the same size, the same order. Remember, 2 by 2, 3 by 3, and so on. So addition is carried out by adding together corresponding elements in the matrices. Similarly, subtraction is carried out by subtracting the corresponding elements of the matrices, as shown in the following example. So as you can see, we have a matrix here, all right? We have this matrix here, and the first matrix is A. So this is our matrix A. We have matrix B, and from our previous class you can see that that's a 3 by 3 matrix. So I said 3 rows 3 columns, and matrix B is also 3 rows 3 columns. That means they are of the same order, okay? And if they have the same order, you can be able to subtract, you can be able to add them. So as you can see, what do? If you are adding, you simply add the corresponding elements in the matrices. So for example, the position 1 1, meaning the first column, the first row is 1. On the other B, on matrix B, the 1 1 position has 4. So you simply add 1 plus 4 to get 5, as shown with the red marker. Then on the next one, on position 1 2, meaning the first row, the second column, you have 3 on matrix A. On matrix B, on position 1 2, we have 2. Okay, then if you add them together again, you get 5. That is shown by the purple color or arrow. Then you go to the next one, which is 4 on position 1 3. So position 1 3 on matrix A is number 4, and position 1 3 on B is 1. Again, adding them together, you get 5. And so on. So you can, of course, following that example, you can of course add 8 plus 5, you get 13. 7 plus, this is 7 here, plus what? 6, you get again 13 here. Then 2 plus 0, you get 2 on this side. Then 2 plus 8, you get 10. Then 4 plus 7, you get 11. Then 9 plus 2, again you get 11. So simply that's how we do addition. So I think it's fairly easy. So you move on to the next one, which is now subtraction. So again, it's the same, exact same thing, remember. So remember, as we started, we had done some laws or some properties of addition that you can commute. There's the commutative property of addition. That means if you add matrix B plus A, you'll still get the same result. But that does not apply to subtraction. Okay? If you do B minus A is not equal to A minus B. So B minus A is not equal to A minus B. They're actually different. Okay? They're different. So that means it does not commute. Alright? It does not commute. So let's move on. So I think subtraction is fairly easy. So you just do, remember again, it's the corresponding elements in the different matrices. So for example, in 1 1, in matrix A we have 1, and position 1 1 on matrix B we have 4. So you simply do 1 minus 4, and thereby you get negative 3, which is on the other side. Okay, which is on that side. All right. So having moved from there, then you do the next one on position 1, 2. You have 3 on the first matrix. Still on the position 1, 2. On B, you have 2. So 3 minus 2, again, you get 1, which is shown by the purple one. Then position 1, 3 on A is 4. Position 1, 3 on B is 1. So 4 minus 1, you get 3. Alright, so that's what to do with subtraction. Of course, you can complete the others. Again, which is fairly simple. 8 minus 5, you get 3. 7 minus 6, you get 1. 2 minus 0, you get 2. 2 minus 8, you get negative 6. 4 minus 7, you get negative 3. 9 minus 7, you get 2. So that is subtraction. So I'll not take a lot of time here because I think this is fairly easy. As you can see on the diagram, at least is very well shown. Then let's go now to operation of matrices. Now you're going to do, of course, you have already done addition, and as I said, there are these properties here. For example, the commutative property. And again, I said, remember, this is addition, not subtraction. So when we say that matrix addition is commutative, or the order of addition matters, that is A plus B is also equal to B plus A. So you see, commutative applies when you're dealing with addition. When you go to associative, it's A plus B plus C. That means matrix A, matrix B, matrix C. You want to add them. You can first add matrix A and B first, then you add C. That will still be equal to first adding matrix B and C first, then adding A, and you still get the same answer. And it's also equal to, I probably would have added this, is equal to also A plus B plus C at the same time, adding them simultaneously. So it's the same. Then if you add a matrix plus the zero matrix, remember a zero matrix is a matrix which has all elements being 0. So if you add the matrix plus the zero matrix, you still get the same matrix. It does not change. Okay. Then we go to now the scalar multiplication. So what is that? Matrices can be multiplied by a scalar, the constant or single elements. Let K be a scalar quantity. Then Ka is equals to Ak, for example. So what is a scalar? It's just a constant, an element, an integer. 2, 3, 4, 5, 6. All those are scalar quantities. So if you are simply either, of course you're not adding, it's multiplication, okay? So a scalar unit multiplies, not adding. Okay? You multiply, not add. I need to be very clear about that. So what do? If you have a scalar unit or quantity, you multiply it by all the elements in the matrix. Again, I repeat, all the elements in the matrix. Just like it's shown there, you have 2 multiplied by that matrix, so you multiply 2 by every element. So in position 1, 1 we have 4, so 2 times 4 you get 8. Position 1, 2 you have 2, so 2 times 2 you get 4. Position 1, 3 you have 3, which is 2 times 3 you get 6, and so on. Alright, so you simply multiply that by every element in the matrix. Again, I won't dwell on that. I think that's fairly easy or simple to follow by. Then now we'll go to the next one, which is operation of matrices. Now, matrix multiplication. Okay, so in this case we are referring to A, B, and C. They are matrices. All right, so there are rules of engagement as far as matrix multiplication is concerned. All right, just don't multiply. So when you have matrix A and B, one, they must be conformable. They must conform for multiplication to be possible. That is, the number of columns of A or the number of columns of the first matrix must be equal to the number of rows of the second matrix B. Okay, now I've shown it there very nicely, showing that what is the number of columns of matrix A? Of course, it's n. You can see n. Of course, n and m and p represent a number. It's a number. But you've just used letters to represent the numbers. Okay, as a general formula or format. So, n being the columns in A and n being the rows in B. That means the number of columns in A must be equal to the number of rows in B for it to be conformable for multiplication. That's why we have said n must be equal to n. So on the practical one, you see the two matrices, which is 2, 3, 1, 4, 0, 2, then 2, 4, 9, 1, 0, 2. Now for the first one, it's a 2 by 3 matrix, okay? Then the second one is a 2 by 3 matrix, so they're the same. But you realize that the columns of the first matrix are 3 and the rows of the second matrix are 2. Meaning they are not the same. Therefore, you cannot multiply them. They have not conformed to the rules of multiplication. Okay? So, the first matrix columns must be equal to the second matrix rows for there to be a multiplication. Hope that is clear. So, the resultant matrix, because of course when you multiply two matrices, you get another matrix. So what is the order of the other matrix? It's actually m times p, as you can see where c is. You can see this c here. All right. So m times p. Where do we get m and where did we get p? So for you to know the order of the resultant matrix, it's simply the rows. You take the rows of the first matrix and the columns of the second matrix. That's why we have there m and p. So m times p. Okay, so for example, I just give a very simple example here. If matrix A is a 3 times 2 matrix, then multiplied by matrix B, and a matrix B is say 2 times even 4 matrix, like that. So what will be the resultant matrix on the other side? Matrix C will be of which size? Okay, so it will be of size number 1. Pick this one, so 3 by, then you pick the what? The columns of the second matrix, so it will be a 3 by 4 matrix. Okay, to be a 3 by 4 matrix. And again, you can still note that this 2 is equals to this 2. That means you can multiply them. Okay, that's how we do that. So we're dealing here with matrix multiplication. And we are going to deal with two types of matrices, which is 2 by 2 and 3 by 3. So of course we say 2 by 2 is 2 rows and 2 columns, 3 by 3 is 3 rows and 3 columns. So multiplying elements in the first row with all the elements in the first column first, then the second column, then systematically move to the next row and multiply it with the first column, then the second column. So I want you to be very keen as we do this, because sometimes people end up getting confused about this kind of dance, all right, of multiplying and addition. So number one is that the first matrix, okay, so let's call this matrix A, though we haven't labeled it. Let's just call this A and let's call this B. So matrix A is the one that determines, okay, it's the determinant matrix, if you would put it, if you like it. It's the one that determines how things flow. Okay, why am I saying that? Because matrix A, that's where you start systematically adding and multiplying. So what do I mean? If you're doing multiplication of these two matrices, you always start with the first column. You always start with the first row, not column. Okay, so take the first row of matrix A and multiply it by the 2 columns of matrix B. I repeat again, take the first row of matrix A and multiply it by the 2 columns of matrix B. Okay, systematically. So how do you do that? You start with 2 times 0. as shown by the red arrows, plus 1 times 5 as shown right there. So after you're done now with the first row and the first column in matrix B, now again you're still on the first row, then go to the first row and now the second column in matrix B. So that's going to give you 2 times 2 plus 1 times 1. Okay, so just before I move on, there is something I showed you in our earlier class. So when you have a 2 by 2, because this is a 2 by 2 matrix, this other is a 2 by 2. So what kind of resultant matrix do you expect? You expect a 2 by 2 matrix. So your resultant matrix is going to be again your 2 by 2 matrix. So 2 by 2 matrix has 4 elements. Okay, so there is the first element, which is 1 1. There's a second element 1 2. Then there is 2 1. Then there is 2 2. All right, so those are the positions of the elements of our resultant matrix. Resultant matrix in this case meaning the result you get after multiplying the two matrices. So now, how do you know where to place the numbers as you add and multiply them? The simple thing is, take the first, so in this first position, okay, remember you're in this first position, so in this first position 1 1, it means the first row of the first matrix and the first column of the second matrix. So right here, what we just did here, this one, so that's our first position. Then the second one, of course, is 1 2. 1 2 meaning the first row and the second column. So what we are talking about is this one right here. So this is our other element. Now we were actually now in our second row now. So now we are in this row here. I told you A is very important because it's one that determines all the others. I mean, determines the multiplication, how the multiplication goes. So you start again with the second now row, multiply it with the first right here. So second row, multiply it with the first column of the second matrix. After you're done, you go back to the still the second row, multiply it with the second column of the second matrix. Okay, now of course you're going to put that right here, now in position 2 1. So 2 1 here means second row, first column. Okay, so now when you're doing that, that will be 4 times 0 plus 3 times 5. So in this case, as you can see, there was an error here. This is not 4, this is supposed to be 3. This is 3 right here. So 3 times 5. So 4 times 0 plus 3 times 5. So you'll have taken care of now position 2 1, which is right here. Then now you go to the last one, which is 2 2, position 2 2. So position 2 2 is right here. So position 2 2 means the second row, the second column of the second matrix. So that is going to give you 4 times 2 plus 3 times 1. 4 times 2 plus 3 times 1. And of course you're going to get this one right here. Okay, that's what you get there. So that's how to multiply that. So after you're done doing this, of course now you're left with doing some multiplication and addition. Of course 2 times 0 plus 1 times 5, you get 5. 2 times 2 plus 1 times 1, you get 5. 20, then 4 times 0, of course that's 0, plus 3 times 5, which is 15. Remember we had an error there, so this is supposed to be actually 15, not 20. This is 20. Beg your pardon there. This is 20, not 15. For the other one, it's 4 times 2, which is 8, then 3 times 1, which is 3. So 8 plus 3, that gives you 11. That means now our resultant matrix is 5, 5, 15, and 11. Just like you can see right there. So that's a 2 by 2 matrix. So then we can now go to a 3 by 3 matrix. So ideally 2 by 2 and 3 by 3 in terms of multiplication is exactly the same. The only difference is that a 3 by 3 has a bit more work because it has a bit more columns and a bit more rows than a 2 by 2. But ideally it's the same thing. So what do you do with a 3 by 3 matrix? Now we have matrix A and we have matrix B. Okay? So it's the same rule. Remember how we are going to do it? We are going across the row and then down the column. We do again across the row, down the column. Across the row, down the column. That's what you're going to do for this. Just the same way we did the other matrix, this 2 by 2. So now let's start with the very first one. The very first one is well labeled, as you can see. So we are going to start with the first row, first column in the other matrix in matrix B. So in matrix A, you take the first row, then matrix B first row. So we are in position 1, 1. Position 1, 1. Okay? And position 1, 1, as you can see, it's in red, the first red there in our resultant matrix. So what do? You're going to take 1 multiplied by 4 as shown by that figure there, plus 3 multiplied by 5. Remember, you're taking the row and going down the column. Okay? So you're starting with the first one. The first one will be 1 times 4 plus 3 times 5, then plus 4 times 8. So you see, you have used that row. You have gone this way and that way. Okay, so this is the row the principle that you use. So in our position 1, 1, we are going to have 1 times 4 plus 3 times 5 plus 4 times 8. Then we go now to the next one. The next one is going to be the first row, of course, again, first row, now second column. So now position, remember we had already done positions about elements being positioned. So 1, 2, position 1, 2 now, where we have green, we are going to have 1 times 2 plus 3 times 6 plus 4 times 7. Very well shown there. Okay, and of course you're going to get this. All right, then we go now to the third position, which is 1, 3. Okay, so that means the first row, the third column. Okay, so the first row again is 1 times 1, you get there, 3 times 0, you get it there, then 4 times 2 right there. So we have our element there. Okay, then you are done with that. The next part is that you now go to the second column and now the second row and the first column. So 2, 1. So 2 is A and B 1. Okay, and of course you know that position is right here. Again, if you have not if you don't know how to do positions or know where the elements are labeled, you need to go to our previous lesson and just check it out and then come back here. So what I'm saying is now we are in position 2, 1. So 2 meaning the second row of the first matrix and the first column of the second matrix. So again, that will now give you 8 times 4 plus 7 times 5 plus 2 times 8. Alright, then we go now to the next position, which will again be 2. Again, we are still in row 2, column 2. So 2, 2. At position 2, 2 will have 8 times 2 plus 7 times 6 plus 2 times 7. So you get this. Alright, then you go to the next one. The next one will be now again the second row of the first matrix and the third column. Okay, so we are at this position, which will now be 8 by 1 times plus 7 times 0 plus 2 times 2. Now after having done that, now we are done with the second row. Now we go now to the third. All right, we go to the third one, the third column, the third row. So third row for A and first column for B. Now we are at this position here. So that will be now 2 times 4 plus 4 times 5 plus 9 times 8. Okay, and we are done with that. So then we go to the next position now. The next position now is 3, 2, 3 for the third row and the second column. So position 3, 2, remember it's this one here. Again, we're going to do the same, which will be now 2 times 2 plus 4 times 6 plus 9 times 7. Okay, now you go to the last position, and of course, so far you know the last position is usually 3, 3. So the third row for the first matrix and the third column for the second matrix. So again, you're right here. So that will be 2 times 1 plus 4 times 0 plus 9 times 2. So finally, after getting that, after adding that or getting those, you just need now to add them up and multiply them, and then you're actually going to get this answer here. So it's as simple as that. Okay, now I wanted us now to do a real practical exam situation where you're going to use matrices. Okay, so that we see how do we now do this, because this was just theoretical. No, you can have a practical situation. For example, when you're having a question like this: 2 softball teams submit equipment list to their sponsors. So you have the women's team and you have the men's team, you have the bats, the balls, the gloves, and so on. Then you're told each bat costs $18, each ball costs $3, and each glove costs $25. Use matrices to find the total cost of equipment for each team. That means you should use matrices to get the cost of the women's team and to get the cost of the men's team. So what should you do? So this is now the application of matrices. Okay, a part of application of matrices. So what you do is you write this in form of matrices. Okay, so assuming we started with the cost, so you start with 18 right here. So you do 18 and then 3 and then 25. These are the costs of those items. Then of course, remember this is a matrix, and then multiply this by what? By our bats, balls, and gloves for the 2 teams. So again, you write it in matrix form. So this is 12, and then you have 15 here, 45 and 38, and then you have 15 and 17. So a question is, can you multiply these 2 matrices? So remember, we had the rules for multiplying matrices. So you can do this matrix is a what? It's a 1 by 3 matrix. This other one is a what? This is a 3 by 2. So remember, we said for the matrices to be compatible for multiplication, these columns must be equal to this row of the second matrix. And because they are equal, then you can be able to multiply those matrices. So assuming this was on this other side, let's assume this was on this side. So we put the cost on this other side, so that you have 18 here, you have 3 here, you have 25. And you want to do a multiplication. So now this is a 3 by 2 matrix, and this is a what? 1 by 3 matrix. Is it compatible for multiplication? No. Why? Because this and this are not equal. So you cannot multiply it in that manner. Alright, you cannot be able to do this because they are not compatible. Remember, we had already tackled that. Okay, so that means that we need to change this one to go to the other side for us to be able to multiply. So we have 18, we have 3, we have 25. So now, how do you do this multiplication? How do you do this? Just the same way we did the other one. So for this one, you're going to have the first one, which is 18 by 12, okay, 3 by 45, 25 by 15. So for the first element, remember now we are in element 1, the first row, the first column. So in position 1, 1, we are going to have what? 18 times 12 plus 3 times 45 plus 25 times 15. That will be the first element. Now the second element, that is the first one. The second element now will be, so now we are, remember you only have one row. So first row now, second column. So position 1, 2. Position 1, 2 is still up here. So we are going to have now 18 now multiplied by 15 plus 3 multiplied by 38 plus 25 multiplied by 17. All right, so those are just our two elements. So of course when you multiply this you're going to have 216. Let me just do the whole calculation. So 216 plus 3 multiplied by 45 plus 25 times 15. So you're going to get here 726. So the first one will be 726. And now these are the last one here. You're having 18 multiplied by 15 plus 3 multiplied by 38 plus 25 multiplied by 17. And here you're going to get 809, sorry. So this is your resultant matrix, 726, 809. So what is the interpretation? Remember, it's exactly the same way it's on our table there. So that means for the women's team, the total cost there is 726. For the men's team, the total cost is 809. So that's how you do this, all right? And this is a very, sometimes for those who are in the academic place, these are some of the questions that you actually get when you're doing your papers. Okay, so that's how that is done. So that is the application of matrices. All right, so join us next when we are looking now at the determinants. Thank you. Remember to get more content, our upcoming videos, please like, share and subscribe.